So, to begin, I think many of y'all in this room probably have heard about Rehabs and PPA. Some of y'all may not have, some of y'all may have, but I will say, at least for me, the idea of using Rehabs in asphalt is something that's relatively quite new. In fact, probably a year ago, I didn't even know what a Rehab was. And so I figured for this presentation, we would go over what is a Rehab and what is a PPA to give everybody in here a background on what these two additives are that we add to asphalt. We'll also get into basically the problems that we have seen with using Rehab and PPA, and some of these problems are more so as a result of our northern states and even in Canada. And so we'll look at the problems associated with Rehab. I'll give you a nationwide perspective on the use of Rehab and PPA. We'll get into TxDOT's specification and what has TxDOT decided to do regarding the use of PPA and Rehab. And then finally, I threw in this kind of 2-for-1 special. We'll actually get into how we at CST are able to detect the presence of Rehab and PPA in asphalt. So what is a Rehab? So basically, Rehab stands for re-refined engine oil bottoms. So what that basically means is that, as an example, now it includes other oils other than motor oils, but let's say you go and you change the oil in your car. Well, you'll have these industries that will actually take that oil and will re-refine it to pull off different products off that recycled engine oil. And so when we use the term Rehab, there's actually another term that is also used that they call, let's see, right there. So basically they call it the vacuum tower asphalt extenders. But basically what it is that after you get through refining the recovered engine oil, the non-distillable fraction is what we refer to as Rehab. And so when we talk about Rehabs, Rehabs have actually been used for quite some time. Some sources say that they've been used since the 1980s. That's around 35 years, right? And then in addition to that, approximately 160,000 tons of it is produced each year. Now, you might ask the question of, well, so what's the problem? Because if we've been using it for 35 years, well, why haven't we seen a problem with it up till now? And we think that part of the reason is because if you talk to the supplier of Rehab, they actually recommend the dosage to add to asphalt of around 6 to 8%. Well, based off of our testing that we've been doing at CST, we see some Rehab contents upwards of 15% or more. So number one, we think that maybe too much is being used in our asphalts. Why would you use a Rehab? The idea behind using Rehab is that it helps to modify the low temperature property of the binder. So in other words, basically you turn a 6422 into, say, a 5828 or a 6428. And so the idea is that it softens the binder. So why is that desirable? Well, as we all know, we are now using quite a bit of recycled materials in our mixes. And so the idea is that when you use a stiffer binder, it's a good idea to add a softer binder so that our mixes don't get too stiff in the field and lead to cracking. Polyphosphoric acid. What is it? Well, number one, it's produced by the addition of sulfuric acid to phosphate rock. That's the main commercial production. First patent, so again, just like the Rehab, the first patent for binder modification using PPA was filed in 1973. Approximately 10 million tons are produced each year, and about 80% of this is used in the production of fertilizer. Now, what's interesting is that it's also used as a flavoring agent in many foods. For example, If you drank a Coke or a Dr. Pepper this morning, if you look at the ingredients listed on a Coke or a Dr. Pepper, you will see that PPA is actually used in the soft drinks that we consume. The idea behind using PPA is that it tends to modify the high temperature property of the binder. So what does that mean? That means basically now you can take a 6422 and you can modify it into a 70 or even possibly a 76. So these two methods of using Rehab and PPA are basically used as a way to modify the PG grade of asphalt binders. What are some potential problems with using Rehab and PPA? Now, I will say that it seems as though that this is kind of a brand new topic. There's not a lot of literature available for looking at Rehab in particular. And on the literature that I was able to find, this is based off some work that was done in Canada, you typically see some stability issues with it, which means that you can have some problems with rutting. There has been some cases where raveling seems to be an issue. But I think the primary reason why a lot of people or a lot of distress that has occurred has been due to premature cracking in the form of thermal and fatigue. There's also this idea of this physical hardening process, which basically means that the asphalt will experience increased stiffness when stored at a constant low temperature. So as we all know, as the temperature of asphalt changes, so does its hardness. Well, this concept is actually a little different than that because basically you're keeping the temperature the same, but yet you're still seeing the increased stiffness. When we talk about PPA, so one of the big things about PPA, again, it's been around since 1973. The idea behind PPA and its problems is that there seems to be some interactions with some of the new technologies that we use today in our asphalts, which include lime and anti-stripping agents. So in other words, if you have an asphalt source with PPA in it, and then you go and you put in lime or anti-stripping agents to help you with the rutting resistance with the Hamburg results, it seemed as though being an acid, it is tending to counteract these additives that you're putting into the asphalt to minimize the stripping and rutting aspects of your mixes. What I have here is actually a couple of photos. Again, Canada has kind of been the leaders with this, and so they are basically showing you some of the distresses that they observed with pavements that contained Rehab. And the bottom photo is actually one of the first cases that has been discovered. This one is 5-year-old pavement that started to experience quite significant damage, and it's being attributed to the use of Rehabs in asphalt. As far as Texas's perspective, so what have we seen here in Texas? Well, about 3 years ago, we had some Hamburg failures. So we've seen it in the laboratory, and in these Hamburg failures, what we were seeing is that we couldn't get the Hamburg results to pass, no matter if we tried 10 different iterations. You tried changing the aggregates, everything, what have you. And what we found was a solution was to actually change the asphalt source. Unfortunately, this was 3 years ago, and this was before the time that we had the ability to determine how much PPA was in the sample, because that's kind of what we thought might actually be the reason for what we saw. We're also starting to see it in some projects around the state. We're seeing these premature failures that include raveling, color change, cracking, aging. And one of the things about these mixtures that are tending to fail is that they do not contain recycled materials. So I guess what we were thinking at the time is that we had some binder quality issues that our normal PG specs weren't able to pick up. And so the idea here is that we needed a different method of analyzing the binders to see, okay, can we determine why these binders are failing in the field? And what I have here, that is not actually a camera, I guess, it's not a camera. It's the same photograph that I took on my iPhone of a PFC job that were spaced about a month apart. And you can see when they first, the top picture, basically you can see nice, black, shiny, exactly what we thought a PFC would should look like. And you can see what it did a month later. You've got this dull kind of pavement that's not performing very well, right? And so this particular pavement actually came back through our testing with about 11% Rehab. So we are starting to see some evidence of the effects of using Rehab in asphalt. Now, in terms of a nationwide perspective on Rehab and PPA, so as we said, Canada has kind of taken the lead on this. In 2010, you had some municipalities in the province of Ontario that have strictly outright banned the use of Rehabs. 2014, you had the New England states that basically followed suit and did the exact same thing. And then what was interesting is in terms of Rehab, a recent survey by AASHTO that I found on the internet reported that about 71% of the states that participated in the survey had no specification for Rehabs. And so what that means is that they probably aren't very aware of it, but they are becoming more aware of it as time progresses. In terms of PPA, there were 3 surveys that were done, 2 by the Pennsylvania DOT and 1 by the Ontario Ministry of Transportation back in 2002, 2007. And if you combine the surveys, you can see the results. Basically, 12 states actually had no restrictions on the use of PPA in asphalt. 15 states had actually banned the use of PPA. 14 have restrictions and 7 remain neutral. So what's TxDOT's stance? Well, so TxDOT decided beginning in August of 2015 that they were going to limit the amount of Rehab and PPA in PG binders. That limit was 5% for Rehab and 0.5% for PPA. And so TxDOT decided to take a proactive approach. There's a lot of conflicting literature right now. Again, this topic of especially Rehabs is a little bit unknown right now, but we wanted to be proactive and say, okay, don't know for sure if we've got a major problem or not. We're not sure what the correct dosage is. But let's go ahead and cap a certain dosage just so that way we can start, you can always change those limits, right? But we wanted to, for safety reasons, I guess, we wanted to make sure that we had some sort of specification in place. So I'm going to switch gears here now because I'm going to talk about what we do at the construction division to not only detect the amount of Rehab and PPA in an asphalt, but also how we go about quantifying how much Rehab is in the asphalt. And the reason why it's important that you want to quantify it is because if you have a specification, you need to make sure you know how much Rehab is in that sample so you can see if it's compliant with the specification, right? And so the technique that we use at CST Construction Division is basically what we call a Wavelength Dispersive X-ray Fluorescence Spectrometer. It's the name brand of the spectrometer that we use is actually the Rigaku ZSX Primus 2, and it's a 4 kilowatt spectrometer. And so basically what XRF does is it does what's called an elemental analysis. What does that mean? Well, that means that basically it looks for elements within the sample that you're using to analyze. And so the idea here is let's see if this method would work to tell the differences in elemental compositions of asphalts that contain Rehab and PPA versus asphalts that don't. And so I just did a quick Google search and I was like, okay, well, let's look at lubricating oils, right? So what elements are present in lubricating oils, right? And so basically you have different metals, wear metals, as you can expect. As the engine oil is running through the engine is breaking down. It's contributing metals to the oil. And so when you go to change it, these metals are present in the engine oil. you have oil additives, you have antifreeze additives, and you have contaminants. And the reason why I have these particular elements highlighted in red is because you will see on the next slide that these are the elements that we are actually looking for that are able to determine whether or not Rehab and PPA are in the sample. And of course, when you consider PPA, there's the chemical formula for it. You can see PPA has phosphorus in it, right? So that's one element that we would look for. And so when we went out and said, okay, let's test a sample, virgin asphalt sample, we know it doesn't have any Rehab, stick it in the XRF, let's see what we measure. So what we found is that in all asphalts, you're going to see iron, nickel, sulfur, and vanadium. When you actually start to add Rehab to the asphalt, you can see in the dark or in the highlighted black elements there that you can see with Rehab, you start to see phosphorus, molybdenum, zinc, copper, potassium, and calcium. And then whenever you look at asphalt with PPA, you obviously see phosphorus. Now the question was, okay, so this is basically saying we can detect the presence of Rehab and PPA in asphalt. The question is can we quantify it? And to answer that question, we need to know, do the intensities of these elements correlate with the concentration? So what I have here is basically a graph that's showing the intensity of the 6 different elements. This is for Rehab. This is a calibration standard that we use. It's basically the 6 elements that we use to determine that Rehab is present in the asphalt sample. On the y-axis, you have the intensity that's measured by the XRF machine. And on the x-axis, you basically have an asphalt that we essentially doped with different quantities of Rehab. And you can see based off this graph that you get extremely good correlations. You get R squared, I mean, look at the R squared value of the calcium, right? It's 1.000. So you get extremely good correlations between the intensity of our machine and the dosage of Rehab. And that is something then that allows us to be able to say, okay, I've got an unknown sample, so if I can measure the intensity of these elements in that unknown sample, so number one, if they show up, number two, if you measure the intensity, you can actually correlate that to the dosage of Rehab. When you look at polyphosphoric acid and phosphorus, you basically see the same thing. You see these very, very accurate, very, very good correlations between the phosphorus intensity and the amount of PPA that you have in the sample. Now, here's the deal. So we have found that in terms of detection, when it comes to determining if there's Rehab or PPA in the sample, there is no question that we can say yes or no, it's not in the sample. The challenging part of this is being able to quantify it. Reason being is because we have found that crude source seems to have an effect on the Rehab quantification. It seems to have an effect on the intensity readings that we measure by the XRF. This effect doesn't seem to be nearly as bad for PPA. We have also found that not all Rehab sources are the same. So as you can imagine, if you've got one supplier that's pulling in engine oil from a diesel vehicle, and you've got another one that's coming in from, let's just say, a regular car type thing, you're going to see differences in these elements within that Rehab, which is going to show up in your asphalt when you run the XRF. Basically, that's the key there, is that these different Rehab sources are containing different amounts of elements. We also found that the Rehab, currently we don't know how consistent Rehab is. So if I grab a sample of Rehab here, let's call it October, and I come back in June of next year and grab another sample of Rehab, we're not quite sure of how consistent those samples would be. Now, it does appear that there is a lot less error whenever you consider PPA, and that's probably because PPA is a man-made product, right? It's made by the addition of sulfuric acid to phosphate rock. So it's pretty much a very uniform product, if you will. Now, I have that picture there because that picture basically shows you what Rehab looks like. So Rehab is basically fluid at room temperature. and it's quite interesting. So what are we doing? What are we doing to try to improve our method to increase the accuracy? There's one thing that we have found that seems to be unique to other researchers in the world that are looking at this. And then basically our idea was to determine if there were any key elements present in all asphalt samples that might help to normalize and reduce the error. So if you recall on that previous slide, we basically had sulfur, vanadium, iron, and nickel in all asphalt samples that we looked at. And so what we found is that sulfur and vanadium tended to give the best correlation to reduce the error. We got the next slide, I think will help explain this a little bit better. But another way that we decided to do it was to increase the number of standards. But when we did, we wanted to make sure that we used standards that had varying amounts of sulfur and vanadium. So that may not make a lot of sense, but hopefully this will. So every asphalt, like we said, has sulfur and vanadium included in it, right? And so what I have here, the little white circles, are basically 250 asphalt samples that we've tested using the XRF. And you can see, so number one, you can see some interesting trends, right? Number one, it doesn't appear that there are asphalts that tend to have low sulfur, high vanadiums. You kind of get this 45 degree to some degree aspect of it. So number one, that's kind of interesting. Number two, this graph is a little cluttered, but you can start to see some delineations here, right? There's not a lot of asphalts here, and you know, possibly right there. But the idea here is okay, so if we have a standard and we have a known sulfur and vanadium content with that standard, the idea is to, when you go to take an asphalt sample, that you have an unknown amount of, so this is for Rehab too, by the way, because we said PPA was a little bit more accurate, right? So when it comes to Rehab, if you have an asphalt sample that you don't know how much Rehab is in the sample, the idea here is to match that sulfur and vanadium content of that unknown sample with your standard. And so what I did here is I actually shaded in the different, you said we used 4 standards. I actually shaded in the areas where basically depending on your sulfur and vanadium content that you get on the sample that's unknown, you would actually use that particular standard to calculate the amount of Rehab in your sample. So what are we also doing? We're also monitoring the Rehab composition over time. Like we said, we don't know how consistent it is. There is something that we're doing in terms of Rehabs. We may be able to separate Rehabs. One thing that we're looking at is the manganese. That seems to be a key element that might be able to tell us one Rehab from another. We're also beginning to look at AC binders for seal coats, that hot applied seal coats in particular. We think there might be quite a bit of Rehab in those samples as well. And one thing I wanted to say is that in terms of projects, we wanted to make sure that we throw out the invitation to anybody that might be having trouble with either a seal coat, with the HMA, with warm mix, to basically send us in a sample. If you think that Rehab might be a problem or PPA might be a problem with your asphalt, please send us in a sample. We'd love to test it. Now, just real quickly, the other thing that we're trying to do here is we're trying to look at binder tests. So we're having the Center for Transportation Research do some research for us that basically is looking at Rehab in asphalt binder and how it affects the property of that binder. And not only that, but they're using the non-standard binder tests because, again, we're not seeing, or the current PG binders binder specifications don't seem to be addressing the problem. At the end of the day, this is the idea, this is the direction that we want to head because we think that, number one, the effect of PPA and Rehab does depend on the base binder. Some binders might be able to accommodate more PPA or Rehab than others. And at the end of the day, we want a performance-based test that basically tells us how much Rehab to use instead of prescribing a limit. We also have a research project that's looking at the hot mix properties. Just real quickly, this is being done by our friends at TTI, and I just outlined kind of the 3 main topics here. Hopefully this project will allow us to determine the maximum amount of Rehab and PPA and HMA based on engineering properties. It might help us to influence the Rehab on oxidation aging, and hopefully help us define the maximum allowed Rehab use in hot mix seal coat binders. I wanted to say thanks to several people that are involved. I stole these photos off of the Crossroads, but I wanted to say thanks to Carmen, Andre, Daniel, and Clifton. And I've got this slide as my last slide, and I'm willing to take any questions. So y'all can tell what I'll be doing this weekend. So
thank you, Ryan.
So
we've got time for a couple of questions. Anybody got a question for Ryan?
yes, sir. How much asphalt do I need for testing? Yeah, I need 7 grams. So if you send me a quart, I've got more than enough asphalt to be able to look at this. So.
Other questions?
We did some aging ratios. Okay. So on that PFC mix. Okay. On that PFC mix, your question was. Was the failure the result of a very early oxidation, very high early oxidation? Well, I will say that we did some testing with the extraction process, and we found that basically the aging ratios were extremely high. And so, yes, we think part of the reason why that pavement was showing the distress it was showing was because of early oxidation. Yes, that binder was very, very stiff. Yes, sir.
Have you noted any effects if you're reusing rubber or asphalt?
We are looking at GTR. Okay. As far as chrome rubber and what was the other one? Shingles? So as far as shingles go, we haven't looked at shingles. Now I will say that we did look at a hard pin as one of the asphalts that we looked at. Is it same as shingles? It's probably fairly close. Now I will say that we are also looking at ground tire rubber in addition to PPA and Rehab, and we are finding that we actually can determine the difference between both Rehab, PPA, and GTR. So it's based off the elements that are present in all 3 additives.
My question was more, are we seeing, or is anybody looking at whether we see the deleterious effects of the Rehab PPA if we use rubber?
So as far as that TTI project that's going on, I don't believe that was part of the scope, but that might be something that we want to consider to add to that scope. I can talk with folks at TTI because that's a good point. It's a good point.
One more question.
Yes, sir. Yeah, so the question was, could we have caught the oxidation or the aging of the asphalt by doing an RTFO or PEV? Now, I have looked at some research, and the answer to that is no. Now, there is some indication that if you age it longer in the PAV, that you may start to actually see this. But with the standard method that we use across the board, it looks like it's not detecting the presence of aging with Rehab's aging the binder with the normal testing that we do.